First off, elasticity simply refers to the responsiveness to change. And when we're talking about demand elasticity, or technically speaking, the price elasticity of demand, we're talking about how responsive is quantity demanded to a given change in price. We know because the demand curve slopes down that when price goes up, quantity goes down, but we want to know how much. And elasticities of demand can be labeled elastic or strongly responsive. That means the quantity changes proportionately more than the price. So if the price goes up by, let's say, 50%, quantity might go down by something like 90%. That would be elastic, strongly responsive. Unit elastic, where price and quantity changes are equally responsive. They change by the same proportion. So if price goes up 20%, quantity goes down by 20%. And then inelastic, quantity is weakly responsive to changes in price. Quantity changes proportionally less than the change in price. So if the price doubles, increased by 100%, quantity might only go down by something like 5 or 10%. Okay, and when we get into the problems, we'll talk about different kinds of goods that have different elasticities. We're talking about elasticity, which is responsiveness to change, or you can think about it in terms of the responsiveness to a force that's acting on an object. In the case of demand for a product, the force is the price change. But let's take something that is elastic that we know about, a rubber band, and the force acting on it will be my hands pulling it apart. So I apply a given force, and the rubber band easily moves. This is highly elastic. I'm applying a very light force with my hands, probably maybe a pound worth of pull, and this thing stretches quite a bit. So that's elastic. It moves a lot in response to a given force. Now something that's not elastic, my ruler. I'm applying the same force. In fact, I'm pulling probably even a little harder, but I apply the same force and this thing doesn't move at all. This is very inelastic, so it's not responsive to being acted on by a force. So here's something that's inelastic, doesn't really move or change in response to that force. Here's something that's elastic, moves a lot in response to the force. So what's something in between? I'm going to find something that moves just a little bit, but my tie, the fabric will move. If I pull on my tie, same force, it moves a little bit. So this is slightly elastic, but it will have a low elasticity coefficient. The rubber band would have a high elasticity coefficient, and my ruler would have a very low to zero elasticity coefficient. Okay, so we hopefully have a good intuitive understanding of what this concept of elasticity means. And let me note before we move on that demand and supply elasticity are completely analogous concepts. So if I jump to the definitions of supply elasticity, everything's the same. And notice I've just replaced the word demand with supply here. Price elasticity of supply is how responsive quantity supplied is to a given change in price. Then we can say whether it's elastic or inelastic. Okay, one more quick definitional item. The concept of measuring elasticity with elasticity coefficients, which we'll start doing in some sample problems in a moment. That's indicated with the Greek epsilon, and that can be either greater than 1, which we'll label as elastic officially. It's equal to 1, that's unit elastic, or it's less than 1, being inelastic. Let's talk about the formula for elasticity, and we'll notice here that there's a problem that could skew the results, so we'll need to make a refinement of our formula before we can actually apply it to some problems. The basic formula is really simple. It's just a percentage change in quantity demanded divided by the percentage change in price. So we're looking at a typical demand curve. Price goes up, quantity goes down. Price elasticity, therefore, is always negative. Price is going up, quantity is going down. That means the numerator is negative. Or if price is going down, quantity is going up. That means the denominator is negative. So price elasticity is always negative. And we typically will talk about the elasticity coefficient just in absolute value terms. So we know it's negative, so we just want to look at the magnitude of it. Okay, and here's an example using that really simple formula. Price of oil increases by 10%, the quantity demanded falls by 5%, then the price elasticity is, well, that minus 5%, that's the percentage change in Q, divided by the plus 10% change in P, minus 0.5, or just 0.5, as I mentioned, we'll use absolute value. Okay, now there's a problem. Let's say you run a website design company, and you know that at a price of $250, you could sell 8 units per month. At a price of $200, you could produce 12 websites per month. Now, how do we calculate elasticity here? Well, as we'll notice, it's going to depend on whether price is going up or down, and therefore quantity going up or down. Now, the problem is the percent change is going to be different depending on where we start. If we start at A and the price goes up, we'll get one set of percentages. But if we start at B and have the price go down, the quantity up, we'll get a different set of percentages. Specifically, if the price is rising from 200 to 250. That would be a change of 50 divided by the base of 200, so that's a plus 25% increase in price. Quantities going from 12 to 8, that's a change of 4 divided by the base of 12, so that's minus 33. So our elasticity in that case is 1.3, which we would label as elastic because the elasticity coefficient is greater than 1. However, if we start at B and go to A, price is going down, we see the price change is 50 over 250, which is just 20% now, and the quantity change is plus 4 divided by 8, which is now 50%. So now our elasticity coefficient is much higher, 2.5. It's almost twice as large, in fact. So we're going to get a skewed result depending on where we start here. So we want a better method that kind of evens out that effect. So what we're going to do is use what's called the midpoint method. And to calculate these percent changes now, we're going to take the difference in price or the difference in quantity, and instead of dividing it by one or the other endpoint, we're going to divide it by the midpoint or the average value. It doesn't matter what end value and start value we use because we're only taking the difference. So we'll get the same result either way. So whether the price is going up, quantity down, or the price down, quantity up, we'll get the same elasticity result. So we're going to focus on this midpoint method when we calculate elasticities. And for our little example problem here, our percent change in quantity now is the difference, 12 minus 8, or 8 minus 12, if you will, which is 4, divided by the average, 8 plus 12 divided by 2, which is 10. Or you can just visually think about the midpoint here, right between 8 and 12, halfway between 8 and 12 would be 10. Okay? So our midpoint percent change in quantity, the difference, 12 minus 8 divided by the midpoint, which is 4 divided by 10, 40%. Okay, now our percent change in P, likewise, the difference, which is 50, whether we're going up or down, it's $50 change. And the midpoint between 200 and 250 is 225, or if you prefer the average, 200 plus 250, 550 divided by 2 is 225. Okay, so now we've got our midpoint percent change in price, and that's going to work out to 22.2%. Now we calculate our elasticity of demand. Our percent change in quantity, 40, divided by our percent change in price, 22.2. We got a nice midpoint elasticity value of 1.8. Okay, so just to summarize the formulas, our basic elasticity of demand is simply the percent change in quantity divided by the percent change in price. Our midpoint elasticity is the change in quantity divided by the average quantity divided by the change in price divided by the average price. Likewise with supply, same exact calculations except on the supply curve. So when we're calculating elasticity of supply, we're just looking at the percent change in quantity supplied divided by the average quantity supplied, the percent change in price divided by the average price. Okay, let's work some example problems now. Okay, so we're starting off with navel oranges, and you'll notice first off that my price is always in dollars per unit, and the unit here would be pounds. My quantity is always in units per time period, pounds per week. And I did make up these numbers, but they'll be somewhat close to the prices we would actually observe in real markets. So I'm going to start us at $1 per pound. And at $1 per pound, we're going to say that this market buys 10,000 pounds per week. Just label that 10K. Then we'll have the price fall to 85 cents per pound. And at that price, the sales go up to 16,000 pounds. Okay, now when we have a segment of our demand curve here, we could kind of draw a demand curve in here. We don't need to, but that's fine. Now let's bring in our equation, percent delta Q over percent delta P, and remember, using the midpoint formula, it's delta Q over average Q divided by delta P over average P. So it's simply a matter of plug and chug now. Our delta Q is 6. Our average Q is just the midpoint between 10 and 16, or 10 plus 16 divided by 2. It's going to be 13. And I don't need to write the zeros in there. I could if I needed to, but either way, the division problem will be the same. My delta P is 15 cents. And my average P is going to be the midpoint between those, or the average, 0.925. Simply perform the calculations. So the numerator is 6 divided by 13, 0.46. We can round this. And the denominator is 0.15 divided by 0.925, 0.16. Do that, and we work out to elasticity coefficient of 2.875. Let's call that 2.88. And of course, that registers on our elasticity spectrum as highly elastic. And as we might expect with oranges, you've got a lot of good substitutes, other fruits and other food products. So you're not necessarily going to you're not going to get excited about buying oranges until there's a significant decrease in the price. Okay, now another demand elasticity problem. Let's look at the demand for household electricity. And this time we'll make the price go up. It starts at 6.8 cents per kilowatt hour. And at that price, we have 300 kilowatt hours per month demanded. This is maybe for an individual household. The price rises to 8 cents per kilowatt hour. And demand only falls slightly to 290 kilowatt hours per month. And once again, we could kind of sketch in our demand curve there. But what we're interested in is elasticity. So once again, we just want to plug and chug into the formula. The delta Q is a change of 10 kilowatt hours. The average Q would be the midpoint, 295. The delta P is 1.2 cents. And the average Q here, simply 8 plus 6.8 divided by 2. 8 plus 6.8, that's 14.8 over 2, 7.4. Okay, then we work out all this math. We get 0.034 divided by 0.16. And that works out to, I'm rounding, 0.21. Elasticity coefficient of 0.21, well less than 1, so we would label this as inelastic, and this would be quite inelastic. You know, it might make sense when you think about home electricity. There's not many good substitutes, and people are going to be willing to pay higher prices to keep their homes lighted and heated and not necessarily cut back that much on electricity use in the short run, even when the price goes up. By the way, I want you to notice that my percent change in price, 16% here, and back in my oranges example, 16%. So I did exert the same force, if you will, the same price change. And here we see a rather large quantity change, 46%, for a large elasticity coefficient. And here with the electricity with the same price change, 16%, we saw a very small quantity change, just 3.4% for a very small elasticity coefficient. Okay, now let's think about supply elasticity. I'll stay in the agricultural market. Let's think about potatoes, and it's dollars per pound, pounds per week. And I'll start us off at a price of 25 cents per pound and a quantity purchased at that price of 5 million pounds. And price goes up to 30 cents. Now, suppliers, of course, will supply more at higher prices because they can cover higher cost of production. And let's surmise that the quantity goes up to 10 million pounds per week. Okay, we can maybe sketch in our supply curve here, but remember, it's the same formula. So we just need delta Q over average Q. The delta Q is 5 million. The average Q is 7.5. Delta P here is 5 cents. And the average Q, the midpoint between 25 and 30, would be 27.5 or 0.275. Okay, so we work all of this out. We get 0.67 on top divided by 0.18 on the bottom. And that's going to be approximately 3.6. So that's much larger than 1. So we can label this as elastic supply. Okay, let's do one more supply elasticity. Now I'm looking at the supply of 3-bedroom apartments in Springfield. So price now is dollars per month. That's the rent. And quantity is in the units offered per month by landlords in apartment complexes. And we'll say that the price starts at $1,000 a month. And at that price, in this town, landlords offer 2,000 units. And the price goes up to, say, 1,200. And because in the short run, the supply of apartments is relatively fixed, it's pretty difficult for them to increase supply. They might be able to maybe get some units that are being cleaned or repaired and kind of hurry that along and get the supply up just a little bit. So let's say it only goes up to 2,050. And then we have a supply curve that looks something like that. Okay, and we're working with our same formula. Hopefully this is getting pretty routine by now. Change in quantity is just 50. The average quantity would be halfway between 2,000 and 2,050. That would be 2,025. Change in price is $200. The average is going to be the midpoint between here, 1,100. And this works out to, you can do this on a calculator, 0.0247 over 0.187. And when we solve that, we get 0.136, which is well less than 1, a very low coefficient. So we would label this as inelastic supply. And again, if you think about the constraints on increasing the supply of apartments, it makes sense. It's even if landlords wanted to, in the short run, it's difficult for them to build more buildings. Now, in the long run, we might surmise that the supply curve is much flatter, and the same increase in price here would yield a much bigger increase in quantity. So we could think about long run elasticity versus short run. Okay, but for now we're just focusing on calculating that coefficient and getting this formula down. Okay, now we want to move along and talk about some applications of elasticity. There's all kinds of applications for demand and supply elasticities. We'll really just be scratching the surface here, but I want to show you some of these because it's really fascinating what you can do, just a little bit of knowledge of elasticity. Okay, so let's start off with a classic example, revenue maximization. Businesses typically want to increase their revenue, although it's not always the case that larger revenue leads to larger profits, but it often is. So we want to know, do we want to raise or cut the price of the product in order to increase revenues? Now, the law of demand indicates that if you cut the price, you'll increase sales. But will you increase revenues? Well, that depends on elasticity. Is that increase in quantity more or less than proportional to the decrease in price? So let me show you a couple examples. Let's say you're running a cafe and you sell cheeseburgers, and we've got a calculated elasticity coefficient of 1.5, so they're pretty elastic demand. I just start off with some made-up numbers for equilibrium price and quantity to make this example very easy to follow. So let's say you're selling 100 per week at a price of $5. Demand is elastic. That means if we cut price by a certain percentage, we'll have a greater percentage increase in quantity, and that would indeed lead to an increase in revenue. Let me show you. So our revenue is initially 500 here. We're going to cut price by, what is this, $1, so 20%, and our increase in quantity is going to be 1.5 times that, so we're going to have a 30% increase in quantity. So quantity goes from 100 to 130. Revenue now is 520, so we did indeed see a $20 increase in revenue, right? Although we lost some revenue due to the lower price, we gained more than we lost due to the higher quantity. So there you go with elastic demand. When price falls, quantity rises by a proportionally larger amount, leading to increased revenue. Now, does this give us any indication of whether this cafe should decrease the price of cheeseburgers or not? No, not at all. In fact, I'm doubting the cafe is going to decrease the price of cheeseburgers because they only make another $20 with selling an extra 30 burgers. And I'm guessing that the cost per burger is more than $1 per burger. So costs are going to go up probably by more than $30 in order to gain $20 in revenue. So let's look at the case of a product for which demand is inelastic. And I'm thinking of what's something that people are really going to want to buy almost regardless of the price. And I come from Colorado, so I know a lot of hardcore Broncos fans, and they were really excited when Peyton Manning won the Super Bowl. And so they want to get their gear. They want to get their jerseys and hats and whatnot, and they almost don't care about the price. So let's presume that demand for Peyton Manning jerseys, especially right after he won the Super Bowl, is pretty inelastic, elasticity coefficient 0.5. So initially they're selling let's say this is just a sports gear shop in Denver. They're selling 100 jerseys per week at a price of $50 each. Revenue's $5,000. We know that with demand being inelastic, if we increase price, the reduction in quantity will be proportionately less than the price increase. So let's say we increase price by 10%. The reduction in quantity is going to be half that. So the reduction in quantity is going to be only 5%. So what's revenue going to be now? $5,225. And here we see that the increase in revenue from the higher price swamped the reduction in revenue that we got from the lower quantity. So here it makes sense to increase price, and it's clear cut. Costs are lower because we're selling fewer items. Revenue is strictly higher. So here it's a no-brainer decision. Go ahead and increase that price. And so with inelastic demand, if you increase price, quantity falls by a proportionally smaller amount, leading to greater revenue. Okay, so the question of revenue maximization, of course, is highly important in a business setting. And if you're a business manager, an entrepreneur, you can see the importance already of knowing about elasticities. Another business application comes from the arena of price discrimination. And price discrimination is basically the idea of you charge different prices to different customers. If you can find people who are willing to pay more for your product, you can charge them a higher price, maybe increase revenues and increase profits. Now, this is tricky to do, but where it can be done, businesses will do it, and it's going to depend on elasticities. And I'll show you here an example from the airline industry. This is a pretty well-known example, actually. And most people realize that business travelers pay higher prices for the same flight than leisure travelers. And what's going on here? Well, business travelers have an inelastic demand for flight. Business people have to be in a certain location at a certain time. They need those tickets. They're more willing to pay. Demand is inelastic. Leisure travelers don't necessarily have to be at a certain location over a certain time period. They have a lot of substitutes. They could take a car instead, or a bus, or they could do a vacation at home. So a lot more substitutes for the leisure traveler, and hence much more elastic demand. And you can see here we're starting at the same price level. If the airline can identify who the business travelers are, it will want to increase the prices for them, even for the same flight, remember, knowing that the revenue gain from the higher price offsets the revenue loss from lower quantity on that inelastic demand curve. And if it can identify who the leisure travelers are, it will actually want to decrease the price for them, knowing that the revenue gained from the higher quantity over there offsets the revenue loss from the lower price. So what you see is a sometimes pretty steep differential between airfares paid by business travelers and leisure travelers for the exact same flight. Now, the key is, how does an airline distinguish between the two? And there's a few different methods they use. The one I'm most familiar with is trying to find out how flexible the customer is in the dates of travel. Business travelers, they need to be at a meeting or a conference or some kind of event on a specific day, and so they're not very flexible in terms of their travel schedule, whereas leisure travelers are.
Lady, we really need to get to Chicago. It's an emergency. Is there anything you can do?
I can put you in at Salt Lake City by 4, and there's another flight.
I don't have time to go through another city. I need a direct flight to Chicago.
Oh, I can reserve you a flight coming back from Chicago at 5:55. Does that help?
Hi, I'm Earth. Have we met?
I don't think so.
So the airline can kind of probe around and say, are you willing to travel on another day? If the answer is yes, they suspect you're more likely to be a leisure traveler. They'll offer you lower prices. I'll say, let's move on and talk about some public policy issues where elasticity plays a big role. One issue on which I think some really basic economic analysis has a lot to add to the debate and discussion, but is really underappreciated in my view, is the question of prohibition. Can the government effectively outlaw socially undesirable products like alcohol or narcotics? If we have a product for which demand is inelastic, and this is often the case with narcotic drugs, they're highly addictive, and once people get on the drugs, once people develop the habit, they have a craving, or in some cases a physiological need for the drug, and so they're willing to pay potentially very high prices to get it. So we're looking at a case where the demand is often very inelastic, supply can be pretty elastic. And what does prohibition do if we interdict the suppliers, if we have the police out there doing drug raids, kicking down doors, seizing supplies? What this does is shifts the supply curve up, right? And remember, the supply is the cost curve. Seller costs rise because of the higher fines, penalties if they get caught, costs of concealing the production and distribution, costs of operating in the black market, basically the costs of criminality. So costs go up, shifting the supply curve up and to the left. But with demand being inelastic, what are we going to see? Are we going to see a big reduction in quantity? No, at our new equilibrium, what we mostly have is a higher price. We have significantly higher price, but a paltry reduction in quantity. And remember the effect on revenues. Revenues increase at higher prices for an inelastically demanded good. So the post-prohibition revenue is much higher than pre-prohibition revenue. There's a little bit of a decrease in revenue from the lower quantity, but that's more than offset by the increase in revenue from the higher prices. So what we have now is more revenue, more money to be made in providing this good, but it's an illegal good. So what kind of entrepreneurs are going to be engaged in that business with pretty lucrative potential profits, but high costs of criminality? Well, what we're doing basically is inviting people who specialize in criminal methods to take over these markets completely. And what we might wind up seeing because of this is an increase in violence in return for paltry reductions in the usage of these illicit products. So you see the cartelization and criminalization of drug markets. The same thing happened in the U.S. in the 1920s with alcohol prohibition. We had a significant but not huge decrease in consumption, but that was arguably offset by huge increases in criminality, a lot of murders. We handed over the markets for alcohol to very violent gangs, and instead of engaging in market competition and advertising and trying to become more efficient and pull costs down and then offer lower prices, the way these criminal gangs compete is by going and offing their opponents. So you see a lot of gang fighting, a lot of murders, and high costs, of course, for the legal system of trying to apprehend and incarcerate all of these thugs. This is why a lot of economists are suggesting that we rethink the war on drugs and shift towards policies of treatment or trying to change people's demand rather than an all-out war on supply, which, due to the inelasticity of demand, is often not very effective in reducing overall use and leads to this undesired consequence of increasing crime and violence. Okay, well, final public policy issue that we can analyze with some help from elasticity is this issue of gun buybacks. These crop up routinely, especially in large cities with high crime rates, where politicians want to come out and in a very public way indicate to their constituents that they are getting guns off the streets. So here's a case in point. I did a quick Google search and I found in the LA Times that the Los Angeles Police Department had some gun buyback events pretty recently, May 2016. So the idea here is that the police are going to allow people to turn in their guns, get paid, no questions asked, no penalties for illegal guns. The idea is that if the police can buy up a lot of guns, we'll have less guns on the street, and then hopefully less violent crime being committed. And you can see that people in this LAPD recent buyback were getting $100 for handguns and $200 for assault weapons. And if you know much about guns, you might be already laughing at those prices. But let's presume that those prices are sufficient to purchase a significant quantity of guns. Is that going to have any effect either on the circulation of guns on the street in Los Angeles or the gun crime rate? Well, what do we know about elasticity of demand and supply? In this case, it's supply elasticity that matters. The supply of guns in Los Angeles, because it's only in Los Angeles where the buyback is happening, is going to be very elastic because you can easily import guns into Los Angeles from San Diego or San Francisco or Oakland or Denver or Phoenix. They're small, they're easy to transport. So the elasticity of supply for any product in a very small local area is going to be highly elastic. So we're dealing with a highly elastic supply curve. It doesn't really matter what the demand elasticity is. Okay, we can analyze this. So here's the pre-buyback situation. We have a price and quantity of guns, and the gun quantity here is really just the horizontal dimension of this. Okay, so there's the quantity of guns on the streets before the buyback. What does the buyback do? It's an increase in demand. So we're going to shift the demand curve out here to D2. But with supply being highly elastic, we see is that the price isn't going to go up very much, but the quantity is going to go up substantially. And the police are going to be able to buy maybe a significant quantity of guns, but they are all going to be extra guns being bought now in addition to what the pre-existing market equilibrium was. So it's not that they're buying guns out of the hands of criminals, they're really just buying up extra guns out of the hands of the public. Some of them might be criminals selling off their extra guns. In fact, if you think about it, if the government's buying up guns, no questions asked, what guns are you going to offer to the government for $100 or $200? Well, I'll go into my gun cabinet and find my old crummy guns that don't work very well, and I'll go ahead and unload those on the government. And I'll keep my good, new, well-functioning guns in hand for whatever purposes I'm using them. So really what happens here is that supply is elastic. The government winds up buying a lot of worn-out, non-functioning, old guns. Politicians can say, we got so many guns off the street, but did they really take guns out of the hands of criminals? Okay, the price has only increased a little bit, and the quantity of guns being traded after the buyback, now that we're here at equilibrium B, is almost the same size. So we've only reduced the equilibrium quantity of guns by a pretty small amount. So here again, a lot of economists will say, well, the intentions are good. We want to get guns out of the hands of criminals, but the method is faulty because we're not taking into consideration some basic economics here. Remember Thomas Sowell, what matters is results, not intentions. And to analyze whether this will be effective or not, we need some basic economic tools here. We need elasticity-based analysis. Okay, so there's just a couple examples. A lot of applied work in microeconomics has to do with elasticities, and there's more than we've looked at here. There's cross-price elasticities, there's income elasticities. There's a whole world of analysis that this concept of elasticity opens up to us. But it's important to know elasticity of demand and supply to predict consumer or producer responses to price changes. Okay, so here's a nice little chart that helps us review and summarize, and it's often useful to draw the two demand curves that go through the same point. And the rule is that the steeper demand curve is always the more inelastic one. What we have here is the same price change, the $10 price change on this inelastic demand curve causes a proportionally very small quantity change, but on this elastic demand curve, it causes a proportionally much larger quantity change. I'll close with one little hint here. Inelastic demand curves are very steep, and they kind of look more like a capital I for inelastic, and elastic demand curves tend to be much flatter. And if you kind of draw an extra line in here, you can see that it looks like a capital E for elastic.
When I saw this short fat guy with the band between his toes, hey, I laughed so hard 'cause the band